So let's start with another problem. Trailing zeros under the bit manipulation section of InterviewBit. Problem description has given an integer a, count and return the number of trailing zeros. Okay. So the input as follows. Okay, let's see. So we have a given input number is equal to 8. So how can we represent it in decimal? 100. Okay, 1000. 2 की power 4, 2 की power 3, 2 की power 2, 2 की power 1, 2 की power 0. Simple. Okay. So this is, so number of trailing zeros means number of zeros before a set bit. Number of zeros before a set bit. So here number of trailing zeros are 3. Taking another example, number is equal to suppose it 10. Okay. So how can we represent 1010? So number of trailing zeros here is only 1. Set the first set bit before all the zeros. Okay, all the zeros before the set bit, before a set bit. Simple. Okay, so let's take another example. Suppose we have 12. Let's say 12. 101100. So number of trailing zeros here is 2. um, Number of zeros before our first set bit, okay, first. Simple. So how can we solve? So basically uh, we will shift, let's take example of 12, which is 1100. So we will left shift, right shift our number by 1 and checking the LSB, that is least significant bit, is set or not. If it is not set, then we will increment our counter by 1. If it found to be set, then we will return our counter. Okay, simple. Why we why if we why? Because if we found a set bit in first position, so it return all the zeros before it comes. Suppose there is a case in 10100. So we does not check whether the number is equal to 0. So before a number is equal to 0, we will check our first set bit, so that we will return our trailing zeros. Simple. Now we will solve. uh, we make a counter which is equal to 0 for counting number of zeros, number of zero number of trailing zero. Okay, fine. And now we will make a condition. Suppose if our 1 is equal to 0, that there is no trailing zeros, so it will return 1. Simple. So because if we check, suppose our num is equal to 0, so it is only having 1 trailing zeros. Simple. If it is not equal to 1, then while a is greater than 0, while a is greater than 0, suppose we have a condition like that, number is equal to 4. So 100. If we do and we will reach this position, after that there is nothing. So to break the condition, we will put a condition such that a is always be greater than 0. Simple. So while a is always be greater than 0, we check if the last significant bit a ampersand 1 is equal to 0, then we will increment our counter by 1. If it is not a set bit, else we return our counter. Simple. And for decrementing a, for left shifting a, right shifting a by 1. Simple. If uh, in this case it will goes to 0 and terminate our loop to counter counter. Now we will check. It fails. In which test case? Counter ampersand 1 equal to 0 file. Yep. Let's run it again. Yeah. In 18, the expected return value is 0. Our function returns 0 y. Our function returns 0 y. A is equal to 0, return 1. Okay. But it is returning 0. In 18, the least significant bit is set to 0. If we do ampersand, then it should be incrementing. Why it is not incrementing? While a, if a is ampersand counter plus plus return counter, let me check it again by printf where it is exiting. Exit. Exit. Let me check where it exit. Basically exit 0. Okay, it is exiting on right, but we are performing an operation with 1, then why it is not incrementing the value? uh why it is not incrementing? Let's check. Increase. Let's check whether it is printing or not. No, it is not coming inside this loop. It is right. Let me put in brackets. No. Yep. Yeah, it worked. Now we will run. Yep, it will work. Basically we have to put it in braces. Okay, thank you.